Let's now put all these different ideas we've seen together in one curve sketching menu. So what do we look for now? We want to draw a nice graph. We've seen important things like this. Points of discontinuity. We look at the bottom of the fraction. Bottom of the fraction can't equal 0. This one we know that x can't equal 0. We also know things like if I have a fraction and there's a constant on the top of the fraction, then that fraction can't equal 0. So in this case, y also could not equal 0. Other types of asymptotes that are presented. Well, when we've got something like this one, y equals x plus 1 on x, we know the fraction can't equal 0, therefore the whole thing can't equal x. So I must have an oblique asymptote at y equals x. So we've seen those sorts of ideas. But now we can add to it and get a more accurate graph, our calculus. We know stationary points, they're going to occur when the first derivative equals 0. So once we locate those, we can go and classify them. So maximum turning point if also then the second derivative is less than 0. Minimum turning point if it's greater than 0. And then we can find possible points of inflection. And that's when the second derivative is equal to 0, and then we test for a change in concavity. Third derivative does not equal 0, or again, for both maximum points and inflection points, if it's easier, we can just draw up a table of values and test either side of the point and find what's happening there. Other things that might be useful? We know that if the derivative is positive, the curve's going up, and if it's negative, it's going down. That could be useful. And the actual concavity itself. I know the shape of the curve, it's going to be concave up if the second derivative is greater than 0, concave down if the second derivative is less than 0. So all these different pieces of information allows us to get a better and better picture. Let's just draw this simple cubic. Right, I'm going to find my tools, so 3 derivatives I'm going to find for this one because each of them are very easy to find. Locate my stationary points. Right, stationary points occur when the derivative is equal to 0. Solve this quadratic. I get 2 possibilities here. Well, in fact, they're not possibilities, they definitely are stationary points. 1 and 3. Let's test it. Sub it into the second derivative. I get a negative number. So it's concave down. That one must be a maximum turning point. The other one, when I sub it in, I get a positive number. And so that's a minimum turning point. Now, inflection points. The reality is, I don't go and find inflection points unless they specifically ask me to. But for the sake of the example, I will do it. Possible points of inflection occur when that second derivative is equal to 0. Alright, our possibility is that x equals 2. Now I'll go and test this one, and I'll use the third derivative. Well, I'll get a 6, which is not equal to 0. So a change must exist. There is a change in concavity. So yes, that is a point of inflection. Let's draw the picture. Plot those important points. 1 minus 1 and 3 minus 5. We found an inflection point at 2, negative 3. Other points that are easy to find are y-intercept, minus 5. X-intercepts can be easy to find or might not be easy to find. It just depends on the function itself. I think for this one I didn't bother because I thought I don't really want to go and solve that cubic. Didn't look like a nice one. So I'll just draw one in, and the way I get around not having the x-intercept is I'll just stop the graph short of the x-axis. Oh, well, it's going up there. It'll cut somewhere. I just don't really care where. There's my picture. Okay. Ooh, that was nice and quick for today. So we're going to look at curve sketching.